Hi everyone, welcome back to JDCodebase. Today is day 38 of our DSA LeetCode 75 study plan series. And today problem we are solving a real classic tree problem, that is the lowest common ancestor of a binary tree. This one shows up in the interviews all the time. So let's break it down step by step and super simply. So let's see the problem statement. What it say: given a binary tree and two nodes called the P and Q, find their lowest common ancestor. Now, what does this lowest common ancestor mean? The LCA is the deepest node in the tree that has both P and Q as the descendant. And here is the important part: a node can be a descendant of itself. So if P is an ancestor of Q, then Q itself is the answer. So let me make the super easy with a family tree example. Imagine a family: grandpa, dad, and uncle, you and your sister. Now the question is, what is the lowest common ancestor of you and your sister? The answer is dad, because dad is the deepest person in this family tree. So who is the ancestor of both you and your sister? Dad. And now, what if the question was LCA of you and your dad? So then the answer is dad itself, because remember, a node can be a descendant of itself. And if I say, what about LCA of you and your uncle? Now we have to go all the way up to the grandpa, because that is the first person who is the ancestor of both. So that is exactly what we are finding in this problem, just in a binary tree instead of a family tree. Now let's look at this actual tree from this problem. And here I have this 3 as a root node, then the 5, 1 and 6, 2, 0, 8, 7, 4. So if I say P is equal to 5, Q is equal to 1, we look at the node 3. Is 5 in the left side? Yes. Is 1 in the in its right side? Yes. So node 3 is the LCA of this 5 and 1. Now if I say, what is the LCA of P is equal to 5 and Q is equal to 1? Now this time, oh sorry, P is equal to 5 and Q is equal to 4. Now this time's condition change here. Here if we see node 3, 5 is on the left side, yes. 4 is also on the left side according to this tree, yes. So we go on the left. Now node 5 is the node itself. Node 5 is the node itself, and 4 is the in its subtree. This 2 is the subtree of this 5. So here answer is the node 5 is the LCA. So that is the core idea. We go down the tree, and moment we find that P and Q are on the different side, or we land on P or Q itself, that node is our answer. Here 5 and 4 is like you and your dad. Dad here is the 5 and 4 is the 4. You is here 4. So here dad is your ancestor. Now let's write the code here so you understand it. I am using the JavaScript language here, and this is a recursive solution and it's very clean. And here I have this function lowest common ancestor. It takes the root of the tree and the two nodes P and Q. First write the base case: if root is equal to null, and return the null from it. Means first is the base case. If we reach a null node, meaning we went too far down or found nothing, so we return the null here. Next, if root is equal to P or root is equal to Q, then return the root and use the triple equal always. So here root is equal to P and root is equal to Q, then return the root. Means it's a second base case. If the current node is the P or is Q, so we found one of our target, we return it immediately. So this all handle the case where one node is the ancestor of the other. Like in this case, the like 5 and 4. 5 I found earlier, then I have to return the 5 immediately. There is no need to check further for second value. Now next is the let left is equal to lowest common ancestor, and move towards the root dot left side, pass the p and q both the values, and same for the right side, rigst and rigst root dot right. And I think there is some spelling mistake here, so let me just copy this. So this now we go searching. We recursively search the left side and left side subtree. What happened? This why it's making. Yes. So here we just means we go towards the left side and left subtree and store the result in the left variable, and then we search the right subtree and store it in the right side right variable. And if both the values are found, if left and right is found, then we have to return root here. Means this is the key line. If both the left and right return something, meaning we found p on one side, q on the other side, then the current node is the LCA. We return the root. Like, what is the ancestor of you and your sister? Then it's a dad. Like, and we start from the dad, towards the left, towards the right. This is the p value, this is the q value. We found it, and we just return this dad here, means this value here at this root. Now if nothing found, and then we have to return, if left is value, then return the left, else return the right value. Means if only one side found something, we return that side, and this means both the nodes are in the same subtree, so we bubble up the answer we already found. So this is our final code, and let me run this code. This one is the easiest question I see in the tree section of this LeetCode 75 study plan, and yes, it's accepted. So here time complexity and space complexity, let's discuss. Time complexity is the big of n because we visit every single node in the tree once, and n is the total number of nodes. Here we cannot do better than this because in the worst case p and q are at the bottom of the tree, and we have to check every node to find them. And space complexity here is the big of h. H is the height of the tree, so this is the space used by the call stack because we are using the recursion, and you know the recursion stack that says the height. So in the worst case SQ tree, like a linked list, h equal to n, so it becomes the big of n in a balanced tree. And that's it. The whole trick is go left, go right, and if both sides return something, you are at the LCA. If only one side returns something, pass it for upward. So this is the beautiful example of how recursion can solve a tree problem in just a few lines. And if this video helped you, please like it and subscribe to JDCodebase.